Hello everyone and welcome to another video. In the last video we discussed about different deep learning frameworks like PyTorch, TensorFlow and Keras. In this video we are going to discuss more about TensorFlow and we are going to follow the quick start documentation inside in the TensorFlow website and execute the codes and the instructions mentioned there and go through them one by one.
So quick start for beginners, what it says this is short introduction to using Keras. Builds a neural network that classifies images, train this neural network, and finally evaluate the accuracy of the model. So basically using Keras, it is building a neural network to classify images and then finally it evaluates. It is asking to use Google Colab notebook since it is a Google product, but I prefer my own notebook. And how I started my own notebook is by just running this command Jupyter notebook, and I have an environment called AML, and AML already has TensorFlow installed in it. So let's get to it. Let me create a new Jupyter notebook. Let me show it side by side. Okay, so new Jupyter notebook. So let me rename it beginner quick start. Okay, let's import TensorFlow. Okay, TensorFlow is importing. Then load and prepare the MNIST dataset. Convert the samples from integer to floating point number. So basically it has a dataset in Keras and it is using those APIs to load the dataset. Okay, that's great. So the best way to learn something is not copying and pasting. It's basically writing it by yourself. So let's delete this thing. MNIST is tf.keras.datasets.mnist. Okay, so but what is MNIST? I don't know what MNIST is. If I'm just blindly copying and pasting, I won't know anything about it. Let's see what is the type of MNIST. So it is a module. So basically it is a Python module. It will have objects and it will have methods in it. So MNIST.load data, it's probably a method inside the MNIST module. So let's use that thing. Let's see what it returns. MNIST.load data. So it returns a lot of stuff. So basically it returns two tuples. One of the tuple contains the train data and label, and another one contains the testing data and testing label. So let's use that thing. Xtrain, Ytrain, Xtest, Ytest. Okay, cool. Now what it is doing is these are actually images. We can see what kind of images they are because it is not providing any information, but from the code I can understand that it is a 28x28 image, and an image has a pixel whose values ranges from 0 to 255. So here it is trying to normalize that image, but let's verify that. Xtrain dot shape, it's probably a NumPy array. Yes, I'm correct. So training data has around 60,000 images and the image size is 28x28. So let's see if we can visualize one of those images. So let's import Matplotlib pyplot as plt dot how do we plot images in Matplotlib? plt dot im. So let's see what is the argument to this. Come on, I don't know. Let me just pass the image. Xtrain 0. Okay, this is not bad. Okay, it needs some other arguments, but this is how the image looks. So this is a handwriting of the digit 5. Let's check out another image. So this is the digit 0. If we print the label for this image, then it should be 0. Yep, it's 0. Let's print the label for this image, and the label is 5. So basically from this digital image we are trying to detect the digital number. Okay, this is a good task. Now it is using tf.keras.sequential model by stacking layers. Choose your optimizer and loss function for training. Okay, so it is trying to build a model here using keras. So let me just merge all these into one. Okay, let's see, run it again. Okay, cool. Okay, so we'll build our model now. We'll use tf.keras.models.sequential. So it's basically creating a multi-layer perceptron, because each dense layer is connected to the next dense layer, and all the neurons are connected to each other. tf.keras. If you are not sure what kind of model sequential builds, then you can go there and read the documentation. No problem with that. Layers.flatten. Oh, we forgot to normalize our training data. Let's normalize this. X train, X test, X train. Why we didn't need to normalize our data, I explained that in the linear regression demo. If you haven't seen that, then go and see that. That is super useful for beginners at least. Okay, now that we have normalized our data, let's add a flattened layer. So what this flattened layer does is, our input is currently at 2D matrix, so flatten will convert it into 1D matrix. So tf.care, okay, sorry, input shape 28 keras.layers.dense. So 128. So from 28 multiplied by 28, how much is 28 multiplied by 28? 784. Okay, from 784, the second layer, so 784 is the input dimension, then the first hidden layer dimension is 128. Then we can also define activation, which is ReLU, and then tf.keras.layers. Then it is adding dropout, which is a method to regularize our model so that it doesn't overfit to training data. Then tf.layers.dense. So 10. So why is it 10? Why the final layer has only 10 outputs? It's because there are 10 digits from 0 to 9. So it should have 10 outputs. So, and from those 10 outputs, only one of them will be correct, and that will be decided based on our loss function. Okay, we got some error here. Let's see. Init takes from 1 to 3 positional arguments, but 5 were given. Where? Oh, in the dense layer. So keras.models.sequentiality. Okay, it accepts one array, but we actually passed all the arguments at once. Okay, let's pass them. Okay, awesome. So now let's see, can we print our model? No, we cannot print our model. Model.summary. I think, yeah, I used it before, so I know that. So this is the structure of our model. From 784 input dimension, it goes down to 128. From that it has a dropout layer. It does nothing. It doesn't have its own weights, but it only drops some of the neurons, and then the final dense layer. Our model is created, and we can see the model architecture here. Now, for example, the model returns a vector of logits or log odd score, one for each class. Okay, so let's run our training data across this model and see what is our output. The model is not trained yet, it is just initialized with random weights, I guess. Yeah, I know that. Xtrain, let's pass only the first one. Let's see. oh, because it is a TensorFlow tensor. Okay, doesn't matter. So it returns a 1 cross 10 1 cross 10 tensor, because we only, this is number of inputs and these are the scores for each digit. So based on this we will know with this, so these are the logits for each output. So whichever has the maximum value, that digit will be the answer here. Okay, let's move forward. So the tf.nn.softmax function converts these logits into probabilities for each class. Okay, let's do that. So currently these are just values, but if we pass a softmax layer, then this will become a probability distribution and they will sum to 1 in that case. So let's use tf.nn.softmax function and pass all these values again into that. Let's use the numpy function here. I don't want tensors as output. Okay, so now we have got the probabilities. I'm sure they will sum to 1. We can verify that again. Okay, let's run it again and verify that. So they are summing to 1, so this is a proper probability distribution. So according to this, okay, I should have saved it in output. Okay, now let's print output. Now let's see what is the prediction for this image currently. So for that, what we'll do is np.max, I think, output. Oh no, numpy is not defined. Import numpy as np. Okay, this is the maximum probability, but we don't know which index it belongs to. So let's do argmax. So argmax is 8, so that means it is the digit 8, but the first image is actually the digit 5, but the model is predicting it wrong right now because the model is not trained. After we train the model, we'll again revisit this thing. Okay, let's move forward. The losses dot sparse categorical cross entropy loss takes a vector of logits and true index and returns a scalar loss for each example. So this is a cross entropy loss. They've just added a wrapper over it which only takes the digit and calculates the loss. You can go and read the documentation, but I already know what this is. So let's define the loss function. tf.keras.losses. So this is the benefit of using a framework. We get all these loss functions out of the box. Let's see, sparse categorical cross entropy from logits. Okay, so loss function y train, it is the actual label which is 5, but the output we got gives maximum probability to 8. So we don't have prediction, we have output. And numpy again, let's see. So our loss is different here than this guy's loss because of the way our model is initialized. Since it is random initialization, so the weights from this tutorial will differ from the weights that I initialized my model with. So but the loss is around the same value, so it's okay, don't worry about that. Now let's compile the model. Okay, what is compilation model? So here it assigns the loss value and the metrics that it wants to calculate and also the optimizer. So that is the meaning of compilation. Okay, we are still not training our model, we are just configuring our model to use those things. Optimizer is Adam, a loss is loss function, metric is accuracy. Oh, what happened? Metric, it's metrics. Okay, my bad. Okay, model.fit method adjusts the model parameter to minimize the loss. So what this does is it actually trains the model so that the value of this loss function, which is the loss, is minimal. Okay, let's do that. Do not copy. Model.fit, use the training data to train the model, then epochs. Let's run it. Yes, it says epoch 1 training on 60,000 samples. I'm running using CPU currently, so it's not very fast, but if you're using GPU, then it will be very fast. So our loss initially is around 0.3. So since it has already seen 60,000 images, the loss reduced drastically in the first epoch itself from 2.3 to around 0.3. Then after every epoch, as the model is seeing more and more data and optimizing its weights so that it gets minimum loss value, the loss decreases. As you can see, after fourth epoch, the loss is very small. So after fifth epoch, the loss is around 0.07, and let's see what TensorFlow got. So I got 0.0761, TensorFlow got 0.0746. All the values are pretty comparable. So okay, my code is accurate then. So now we'll use the model, the trained model, to evaluate on the test set and get the accuracy. So before that, now that the model is trained, let's go back to our previous example and run the model again on the first image, this image, and see if we are getting 5 now. Let me copy this thing. Oh Lord, let me copy this thing. Yeah. So this is this. So this is the output. Now let's do np.argmax output. So 5. Okay, so the model is trained properly and it is able to recognize this image. This is pretty good, pretty cool, right? So now let's evaluate the model on the test set. This is only one image. Let's evaluate on all the images. Let's see how much data does test set have. So test set has around 10,000 images, and we'll evaluate the model on all the images. X test, Y test. What is verbose? I don't know, I don't care. Okay, so the accuracy is 97% on test set. So the model did not see the test set while training, it only saw the training set, but the model has generalized pretty well, and in the test set also the accuracy has improved, and 97% of the time the model is recognizing the digits properly. And the loss was 0.0745 and accuracy was 97% for TensorFlow documentation also. So it's pretty comparable. Now what is this probability model? The image classifier is now trained to 98% accuracy on this data set. To learn more, read the TensorFlow tutorials. If you want your model to return a probability, you can wrap the trained model and attach a softmax to it. Okay, yeah, we did that before, but probably it is better to wrap it and create a final model which is returning softmax probability instead of this raw logits. So let's do that. Probability model is df.keras.sequential model df.keras layers df.keras.layers.softmax. Okay. Okay, probability model, it's nothing, it's just a sequential model. It just evaluates the model first and then evaluates this softmax layer after that. Probability model, let's evaluate that. X test 5. Oops, what is this? Okay, it is taking the test data, the first 5 test data, and producing the output, and I believe this is the probability distribution, not the logits. To verify that this is a probability distribution, we can do a sum across how do we write dimension or axis? Axis is 0. Nope, no attribute sum. Let's convert this to numpy. Oops. So it is actually summing up across the columns instead of the rows. The rows contain the probability, so we want a sum of all these values, so but instead it is summing across the column. So let's change the direction, and the sum is almost equal to 1. Okay, was this space helpful? I will leave it up to you to decide, but I believe if we did some extra stuff which are not mentioned in this documentation, and I hope you found the way I went through this tutorial interesting and helpful. Don't forget to like and subscribe, and please share this video with your friend if you found it useful. Thank you.